So you guys watching at home, we've already started some group work. They cut pieces of licorice up into 2, 3, 4, 5, 6-inch pieces. They took 3 pieces and tried to form a triangle with them, and that's what you see in the chart. Certain pieces did form a triangle, certain sets of 3 did not, and now we're trying to figure out a pattern between the yeses and the nos. In your own words, before we write down an official theorem, why were these yeses and the nos? Go ahead, Max. Go ahead, Sky.
2 smaller sides added together must be greater than the larger side.
Okay, everyone here, what was just said? 2 smaller sides greater than the third. I'm just going to make it a little bit more detailed. Any 2 sides added up have to be bigger than the third. Okay, take a look. 4 plus 5, 9, bigger than the third. 6 plus 5, bigger than the third. Okay, down here, what's the issue? 2 and 3. Add them up, bigger than the third? No, even though if I go 6 and 3, it is bigger than the third, you find that one outcast, it's a no. And then what's wrong with the last one here, 2, 3, 5? It has to be greater than, not greater than or equal to. It doesn't fly the or equal to. It's got to be greater than. So everybody good before we officially write this down in what's called the triangle inequality theorem, which says the following. In a triangle, like we always start it, what do I call the result when I add 2 numbers together? In a triangle, the sum of 2 sides must be, want to finish that? Yep, larger, I'll put greater than the third side. Equal to will not cut it. Equal to will not cut it. All right, so that's the third fact over the last 2 class days. So you had the exterior angle fact, biggest side across from biggest angle, and now you have sum of 2 sides must be greater than the third to form a triangle. All right, let's apply just the basic of it, and I'll show you what I really need you to do. This is not multiple choice. All right, it's not multiple choice. We're going to go through each of these 5 here, and you tell me yes or no for a triangle. 1, 2, 3? No. Why not? 1 plus 2 is equal to 3. It's got to be greater. Even though, can you still say 3 plus 2 bigger than 1? Yes, but you have the 1 outcast. Good enough for us. That's a no. 2, 4, 5? Yeah, no, yes, no. 2, 4, 5? Yeah. Every combination has to be bigger than the third. 5, 5, 6? Yep. Little bonus. What type of triangle do I have? Isosceles, good. 8, 13, 21. No. 8 and 13 give you 21. 10, 20, 25? That's a good one. So any issues determining it? Now we get to a little bit tougher part, which is, all right, number 2 is saying the following. I have a triangle. 2 of the sides are 4 and 7. Let's describe the possible sides for the third one. So all I want to do right now with you is list them out. What could, because you can't throw out any number at me. We know that now. You can't throw 80. That doesn't fit into the theorem. We'll form a triangle. It has to be certain values. So let's start spitting out some possible side lengths that would fit into our theorem that we just had. Will, 1 length.
6.
Everyone, 6 going to work? 6 okay for the third side? Yeah, that's fine. There's more. Let's go. I want to list them all out. Go ahead, James.
5.
5 work? Will 5 work? Yep. Let's keep popping them out here. Go ahead, Dylan.
4.
4. Okay, we're starting to establish a pattern, everybody, right? Should I go to 3? 3 going to work? Why won't 3 work? Because 3 and 4 are going to give you 7, right? So I got to stop there. All right, let's go this way, increasing. Would 7 work? 7 going to work? Okay, this has got to end sooner or later because I can't have every number. 8 going to work? How about 9? 10? 11. Okay, so you're telling me 4 to 10. But here's the thing, though. I don't want a list of numbers. That doesn't, especially like as these numbers grow wider apart, this list is going to get longer and longer. So here's how I want it written. And some of you may hopefully have been exposed to this last year in algebra. Remember doing inequalities, the greater than, less than sign? And maybe you did problems where you had two of them in the same problem. Compound inequalities, maybe? Yes, no? Okay, so what I'm going to do is I'm going to put an X in between those. And X will be my third side. And what I need your help right now is, what does X have to be in between? Right? What does X have to be in between? So I'll take, so what first thing you guys came up with was 4 to 10, right? So should it be X has to be between 4 and 10? How about those boundaries? Or it's got to be 4 and 10, right? So everyone remember putting on the or equal to? But unfortunately, that's not good enough. You're missing values. 10.1 work? Would 10.1 work? It works, but what's the problem? It's not in the inequality. How about 3.9? Would that still work aside of 3.9? But is it in our inequality? Okay, so we need to adjust what we put as our boundaries here, right? Because if we do 4 to 11 or 4 to 10, we're missing stuff. So let's try to rewrite this. What do you think? I'll turn it over to you guys because my suggestion of 4 to 10 didn't work. I was missing values. So what do you think I should put on the outside here? You got a suggestion, Nick?
3 and 11.
How about 3 and 11? Would that work? Should I put the or equal to here? No, can't have 3 or 11. But now, does it include my 10.1? Does it include 3.9? It would include 3.1. It would include 10.9. So that looks pretty good. And that's the official one right there. So anything between 3 and 11. I do have one last problem, though. And I'm sure many of you can relate to this problem. That took way too long. All right, that took us a solid 5 minutes to list all those values out. Think about what the boundaries had to be for my inequality and finally get the perfect one. That took way too long. So there's got to be a quicker process. What were the two original sides I gave you guys? 4 and 7. And what ended up being the boundaries? 3 and 11. Is there any way you can use the two sides I give you to figure out the boundaries of your inequality a little bit quicker than we just did? Let's think about it. 4 and 7 were our sides, and our boundaries were 3 and 11. Any way I could use those two sides to get to the boundaries a little quicker? Oh, we got some takers here, huh? John, you better be right.
You find for the first boundary, you find the difference between the bigger number and the smaller number, which is 3. And for the other side, you add the two together to get the other boundary.
Everyone get that, or do I need to translate?
I got it.
Add them
Yeah.
and subtract them. Right? Yeah, good, John. Nice work. Add and subtract them. Okay? Feel like a boss now, don't you? Yeah, I'll put you down. 9 and 17, then. Again, the wider the numbers are, the wider the numbers are from each other. You don't want to list them out anymore. It'll take way too long. So now we can just go and say, oh, my sides are 9 and 17. That means X is going to have to be greater than what? 6? 6? 6. 8? But X also has to be less than 26. Add and subtract them. A little bit quicker now. And then finally here, X will have to be greater than 9, but at the same time less than 31. I don't think you want to list all those out, right? So that's the quick way to figure out what the possible third sides could be. Any questions about that? All right, look, you don't screw around. You can eat your licorice as you go. No reason why we don't walk out of here without any assignment over the longer break. Okay, let's get going.